Hello and welcome to the Nutrient Management Lecture. So today we are going to discuss the Nutrient Management Program, and basically Maryland's Nutrient Management Program protects water quality in the Chesapeake Bay and its tributaries by ensuring that farmers and urban land managers apply fertilizer, animal manure, biosolids, other nutrient sources in an effective and environmentally sound manner. So farmers are required to follow nutrient management plans when planning, fertilizing crop, and managing their animal waste if they have animal waste. But even those that are just planting crops have to have a nutrient management plan. It specifies how much fertilizer, manure, or other nutrient sources, wastewater, biosolids, may be safely applied to crops to achieve yields and prevent excess nutrients from impacting waterways. So they're generally required for all agricultural lands that produce plants, food, feed, fiber, animals, or other agricultural products. Maryland law requires that all farmers who gross at least $2,500 a year or more of livestock producers, all farmers that do $2,500 a year, or livestock producers with at least 8,000 pounds or more of animal weight, which for cows, that's just a couple cows, to follow nutrient management plans when fertilizing crops and managing their manure. Because of the complexity, the plans have to be prepared by a certified University of Maryland specialist or a certified private consultant or a farmer who has been trained and certified by the Maryland Department of Agriculture to prepare his or her own plan. The Maryland Lawn Fertilizer Law requires lawn care professionals to also be licensed and certified by the Maryland Department of Agriculture to apply turf fertilizer to properties that they manage, they have to be under the direct supervision of someone who is certified. The nutrient management program, as well as the University of Maryland, provide testing and training for lawn care professionals as well. So we also have the phosphorus management tool. The phosphorus management tool regulations became effective June 8, 2015. And they provide basically a multi-year process to transition from the phosphorus site index, which is what we used to use, to the phosphorus management tool, which is what we now use. This updated risk assessment tool identifies farm fields with high soil phosphorus levels, and then allows farmers to evaluate different options to reduce the risk of phosphorus runoff to nearby waterways and affecting the Chesapeake Bay. So basically this new tool, at first they were just supposed to run the tool to see basically how it takes into account what they're planting, fertilizer loads, but also it takes into account the legacy phosphorus in the soils. So fields with higher legacy phosphorus in their soils, and thus at the greatest risk for phosphorus runoff, are indicated by a fertility index value of 150 or more. And as of now, they're banned from receiving additional phosphorus. Now that used to be 500, and that's how it's been phased in. So it started at one level, and then each year we've added that level to go down to have full implementation. So soils with these high phosphorus levels are typically found on farms that have used manure or poultry litter as a crop nutrient over an extended period of time. If a farm field has less than 150, the farmer may apply phosphorus to the land based on the farm's nutrient management plan. So it still has to follow the nutrient management plan and current University of Maryland recommendations. Farmers with levels of 150 above cannot apply manure and or have to install best management practices to prevent additional buildup of phosphorus in soils that are already saturated. Right now, approximately with the new implementation going down to 150, approximately 20% of Maryland's farm fields have soil phosphorus levels that require the use of the PMT and to not apply fertilizer at this point. So again, they're based on average soil phosphorus levels. So basically these tiers were determined about this transition period I was saying. So the highest risk group, so those had an FIV value between 450 and 500. They began transitioning to using the PMT tool and not applying phosphorus to those fields with the high levels in 2018. So it's about 96 operations managing about almost 11,000 acres. So then we went to the medium risk group, and this is this level from 300 to 450. And they began transitioning in 2019. So in 2019, they had to use the phosphorus management tool to see which ones they could apply and not apply to. And so those that were higher than 300, they weren't allowed to apply. And it raised it to about 250 operations, about 55,000 acres. Then finally, this low risk group. And so this is the new group that is going to begin transitioning to the phosphorus management tool starting this year, this crop year, so in 2020. And this has basically gone from 250 all the way to 1,300 operations that will now be affected by the phosphorus management tool, which totals about 122 acres. So while it doubles the acres, it includes a lot more people and a lot more operations. So in terms of nutrient management, we're going to talk more in class about nutrient management plans and how those are developed and how the University of Maryland Extension Services works with farmers to develop those plans and what that entails. Right now, we're going to transition on to the nutrient trading program. So to be clear, the nutrient trading program is different than nutrient management plans. Everyone has to follow the nutrient management plans if you're in those criteria that I said on the first two slides. The nutrient trading program is a volunteer program that's managed by the Maryland Department of Agriculture. And so some of these slides are coming from John Roderick at the Maryland Department of Agriculture. And what it is it's a program to provide farmers, specifically farmers, with a payment for going above and beyond, okay, for conservation practices that they do. So the practices offset to address new or increased loads associated with the growing population. So we know wastewater treatment plants, development, industrial facilities, with this growing population, there's increased loads, and so they have more nitrogen and phosphorus going into the Chesapeake Bay. So they can, if they exceed their total maximum daily load, the TMDL, they then are forced to buy private purchase of these nutrient reduction projects because they've exceeded their limits. So they buy from farmers these nutrient trading credits that farmers have done for going above and beyond. But there's also retirement credits. So Chesapeake Bay or Ducks Unlimited or other organizations can buy those in order to reduce the load going to, reduce the overall load going to the Chesapeake Bay. So the nutrient trading, we'll go through the website here in a little bit, but for now it's just an overview of the nutrient trading program for Maryland. Again, it's buying and selling of the nutrient credits. So the seller, who's going to be a farmer, would install the best management practice to reduce nitrogen and phosphorus. Those are the two things that this focuses on. I know with watershed implementation plans that we talked about last week, sediments were also included here. We're focused on nitrogen and phosphorus. The buyer maintains the regulatory obligations by using the pollution reductions created by the seller. So the buyer, the wastewater treatment plant, for example, has its regulatory obligations, and it helps to meet those obligations when it can't meet it, but due to growing populations and other development, by buying these credits from somebody else. So now, even though they went over their limit, they bought up, so they now meet their regulatory requirement. The market determines cost. So the more payments there are, the more obligations that they can't uphold, then the higher the price for buying that nitrogen phosphorus credits. If there's more credits than what the market needs, if everybody's meeting their regulatory criteria and we don't have additional nitrogen phosphorus going to the Chesapeake Bay, then the price of the credit would go down. So to facilitate trading, this web-based calculation tool and a marketplace trading registry was established to assess generating capacity, record how many credits there are, these transactions that have already taken place, and provide a means for the public to track the progress of the Maryland Nutrient Trading Program. So again, these fundamental principles is that the agricultural entities are who are going to generate the credit. First, they have to do a baseline requirement and they have to get there. Then when they go beyond the baseline, that's what's tradable. And there has to be verification and certification for these values. How they exchange it is, again, they find that trading partner with the use of the website. They can sell the credits and they develop these trading agreements. And then there's accounting administration as part of that credit exchange. So basically, similar to the watershed implementation plans, there's 58 sub-allocations, TMDLs. And so these are the TMDLs that have been established, the total maximum daily loads. And so if a wastewater treatment plant or something is going above that, then they can then buy that credit. The idea is they want it to be in a adjacent watershed or in the same watershed in which the credit is generated, as well as the it has to be so far, so close to where the credit is generated and where the excess generation is happening from the wastewater treatment plant or other industry. So if you have your producer field, so before your conservation practice, you have a level, okay? Then you have to implement a conservation practice to get down to a really good base load value. It can't just be, this is the way we normally operate, this is what we are. No, you have to be above what you normally do and go down to a new baseline that is a best management baseline. Then we go beyond that base management baseline and we do an additional practice, and that's what we can trade. So this total reduction is after the conservation practice, okay? So again, before the conservation practice is here, then we get down to a new baseline that's like a really good one, and then we can trade once we go above and beyond that baseline. So an example of this would be, this is baseline and credit calculation example. So an example would be you have so much residuals in the soil. So you're going to keep your residuals in the soil. You have total application, you have crop uptake. So this is kind of your nitrogen phosphorus regardless of what you're doing. So you have so much uptake of nitrogen in the soil, you have so much application, and then you have so much that the crop uptake. But then you're going to do conservation tillage and grass buffers. So that's going to get you down to this new baseline. So you've done some practices, the conservation tillage. So you tilled using best management practices, reduces 4 pounds of nitrogen. The grass buffers that you install on the side of your fields reduce 11.5 pounds of nitrogen per acre. And so that's now your new baseline. Then you do cover crops in a water control structure, and that generates 8 more pounds of nitrogen per acre, and that's what you get to trade. And so there's 3 categories of credit generating practices. The first one is the BMPs with approved load reductions. We know how much it is. So that means the peer review has been done. It's already been built into our watershed model, the Chesapeake Bay model that we've already been exposed to from last week. And so uncertainty is already built into the efficiency. So we don't need a separate uncertainty ratio. We know what that trade will, the values that nitrogen phosphorus trade will be. So these were the ones with approved. These are the type 1s. So continuous no-till, a riparian forest buffer, riparian grass buffer, wetland restoration, tree planting, cover crops, both early and late, off-stream watering without a fence, and off-stream watering with a fence. So you're providing a different place for them to water that's not in the stream for your animals. Off-stream, excuse me, watering with fence and rotation grading. So again, these are going to have different levels. They're just all approved. So obviously with a fence, you're going to have a higher level of nitrogen and phosphorus reduction than you would without a fence, but both of them can generate credit. Again, different animal waste management systems, improved waste and barnyard runoff control are examples of things that are approved for credits. So for example, here's the cover crop. We already talked about cover crops, but again, you could have cereal grain, forage radish, legumes. And so the idea is that this is kind of what it means to put the cover crops in. And this practice applies to all lands requiring vegetated cover, and most often on croplands, especially sloping croplands. So this gives you information about that and this is practice code 340. So each of them have a code. So if we look at cover crops, so there is a cover crop program. So not only can you generate nutrient credits from cover crops, but you can also have cost share with the state for planting cover crops. Because again, we talked about the watershed implementation plan, and cover crops were part of that. And when we talked about that last week, we talked about, again, if you have your base payment is no-till of $45 per acre. But if you plant it by October 1st, so it's an early planting, you get to add another $20 per acre because you get a longer period that it's in there. by October 15th, you get $10 more. If you plant a rye, then you get an extra 10 credits because that actually has a better ability to fix the soil. So your maximum pay that you could get is $75 per acre if you use no-till. If you use conventional, it's $65. If you broadcast with light or minimum vertical tilling, you can get up to $65. If you do aerial, it's less at $60. If you do broadcast stock chalk with aerial ground, it's a little bit less because there is more disturbing to the soil. So that's just an example. Another example is no-till stripping. And so again, this practice is conservation. It's you can call it a zero-till, slot plant, row-till, or just the generic term conservation tillage. And so this is basically talking about how instead of tilling all the soil, we're doing it in strips, or we're doing it in other ways to help reduce the runoff of soil. So again, this is an example. So if you do, you could do no-till. And again, no-till still has 15% of the soils disturbed, 85 is not stirred. So you can do one strip or zone tilled, or you can do a vertical pass with a high residue crop that's put there. So there's different levels and you get different values for those levels. Here's an example of practice code 391 would be doing a riparian forest buffer. Here's a grass buffer. So again, all of these have different values, and you have to do them based on these codes that you're abiding by these codes. Okay, this second category, remember we said there's 3 categories. Those were the first categories. The second category are BMPs, best management practices, that require technical review. So these are currently in practice, but they do require review and establishment of efficiencies by a technical work group because the efficiencies are going to vary from farm to farm based on how it's installed. So the credits will be traded, but they may be assigned a uncertainty ratio. So this would be, you know, precision feeding, precision agriculture, conservation, water control substrates, cropland conversion, enhanced nutrient efficiency, commodity cover crops, so not just the rye, but ones that you're going to actually harvest and sell, and ammonia emission reductions maybe coming from a chicken house or something. So these are where we just have to go farm by farm because each one's going to be different. We can't just give a blanket value. And then finally, the third practices are BMPs that are quite innovative. So they're not currently widespread used. And so we do them on a case-by-case basis. And then they'll establish for this farm, this is what they're going to be based on the installation, the operations, the maintenance, and the monitoring. So it has to be monitored. And then again, it'll have an uncertainty ratio. And then again, it'll be reviewed. You have to submit a proposal for these, and it'll be reviewed by a technical work group. So in these category 3 BMPs is algal turf scrubbers, oyster aquaculture, alternative crops and switchgrass, manure incorporation, both that's incorporating it into the ground as you incorporate the manures you're spreading onto the fields instead of putting it on top for both dairy and poultry, as well as phosphorus absorbing material. So this might be a drainage ditch that has some sort of phosphorus absorbing material in it. So we'll talk a little bit more about that in class. So we are going to talk about algal turf scrubbers, not in this lecture, but in the next lecture, where we talk about what that is, and it's an algal attached to a turf where they scrub out the nutrients. This is an example of a type 3 BMP that we will discuss in further detail with the next lecture. And this is the algal biomass that takes up the nutrients there. So again, the nutrient trading program. So this is the website for Nutrient Trading Maryland. And so you can log into it, and I have logged in and have an account just so I can see what's going on. But they did this year, they did the newest version of that. And again, so if you've already have a BMP, it's already been transferred to the new version, but we might have to rerun the lettuce version because again, as research comes in, those BMPs are getting different values for the nitrogen phosphorus based on the modeling. And again, they have technical reference guides and everything that you need here in this program. The other thing they have is a cost tool. And so this is an example of their cost tool. So again, we talked about, the first is the BMPs that you have to do first before you get to trade. And so here's some examples. So here, this one person said yes or no. So they said yes to conservation tillage, yes to nutrient management. And so they already have the average annual cost based on how many acres they put in here for the things that they're already doing, cover crops and conservation planning. Then this is what they're going to do to generate credits. So they're going to add a forest buffer, and they're going to add precision agriculture. And so from those, they're going to do 1.6 acres of forest buffer and 12 acres of precision agriculture. And so then they said this is a typical lifetime costing, and this is the average annual cost that they're estimating. And so based on this worksheet, the total number of credits that they would generate for those last two things they were doing, precision agriculture and forest buffer, is 3 credits of nitrogen and 2 credits of phosphorus and 1 credit of sediment. So they do trade sediment as well. I'm sorry, I misspoke before. And so to generate the credit, so the average annual cost to meet the baseline is so much for them to do these practices to get down to the baseline, and then how much they need to generate these credits and how much total to generate the credits and the baseline. And they base it out based on nitrogen, phosphorus, and sediment, how much it is per credit. So this is an example of how they use these values. These are just estimates, but basically they have different states and different BMPs that they put into place where you can learn more about that, the units, the lifetime, and then the cost. And so these are, and then how much they might have cost shared. So how much they may have got a grant to help offset this cost. And so we're going to zoom in on this. And so here we have some pasture fencing, for example. So it's going to last about, this one, some of them were 19 years, 15 years was their estimates. This is the installation cost, so the annual cost, and the rental that they might have. So the total annual cost, the annualized value is here. Forest buffers, again, costing about $1,000 here to do. And so they have an annualized cost. Wetland restoration, again, different values. And this is on a per acre basis. And so this is how much the analyzed cost is, and then graft buffers and so on and so forth, so that you can get a better idea based on existing systems. So one of the things that we're going to do, and we'll talk about this in class, but your mini assignment for Thursday is to actually look at this nutrient trading credit business model and to create your own kind of, what if you were going to do a business where you helped establish these nutrient credits for the farmers and helped manage them. And so what would be your kind of one-page business plan talking about how you'd implement your credit? What's your business model? What research might you want to do to make sure that you're proposing a new one, or even for an existing one, to make sure you're getting all of the credits? Or if you have an enhancement to a BMP, how that enhancement would be quantified. How you would verify these reductions and help your client manage the credit, and if there's any policy changes you might want to include this the trading program in your specific business. And again, these are just some examples, some ecology-based examples, but you can pick whichever one you want. But these are things that might involve ecological design. So that's our lecture on nutrient management. Thank you very much for listening, and I will stop the video now.